Hello, my name is Jake Puzicki, and this is an ACT Science Research Summaries question. So this question is asking you to test, or it's really is testing your understanding of the experimental design of this experiment, specifically of experiment 2. The question reads that there was an error in making the phenolphthalein solutions added to each test tube. So in experiment 2, we're looking at these. If we look at experiment 2, we see that there are all these different test tubes where they put different amounts of phenolphthalein and potato juice in the test tubes to see what change occurs in the pyrocatechol solution. So what they're saying is that there was an error making the phenolphthalein solutions. So in this column right here, these solutions, so that the second half of the test tubes received solutions with double the concentrations of those in the first. So 1, 2, 3, 4, 5, 6. 1, 2. So I think this is 6. So like this half received the original like 1 times the concentration, so the same concentration as it was originally supposed to, and this half, so these test tubes received 2 times the concentration, or twice the concentration of phenolphthalein that the first ones did. So here's the first ones, and here's the second ones. 1, 2, 3, 4, 5, 6. Great. Yeah, so the first half received the normal concentration, and then the second half received twice the concentration. So each drop contained twice as much phenolphthalein as the first test tubes. So the question is, how would the number of drops of phenolphthalein required to produce the same results need to change? So assuming that we wanted to get the same color changes, because the concentrations are different, we're going to have to change the number of drops of phenolphthalein that we add from the first batch to the second batch. So in a question like this where we have really complicated answers, what we're going to do is we're going to go answer by answer and either eliminate it or validate it. So let's start at the first one. The first set of test tubes receiving the original concentration of phenolphthalein would need half the number of drops of phenolphthalein as those receiving the double concentrated solution. So the first answer choice is going to be incorrect, because if we gave half the number already, if we put the same number of drops of the first solution and the second solution in, so the same number of drops, these test tubes would have twice as much phenolphthalein because it's twice as concentrated. So if we put half the number, it would be even. I think it'd be a quarter of the concentration as here. So this is going to be wrong. The first set of test tubes would need twice the number of drops. And so that makes sense to me, because if we have twice the concentration in these test tubes, we only need 1 drop for every 2 that we do here. So if we put 2 drops in here in the first batch of test tubes, it would actually come out to the same amount of phenolphthalein as in the second batch. So that one seems like that could be right. So we'll leave that one as a contender. The third one is no change. We know this one's wrong, because if we did this, if we just left it and we put the same number of drops with the different concentrations, then this would be half as potent. It would be half as much phenolphthalein in these ones as in this, would give us different results. And the last answer is the first set of test tubes receiving the concentration received the same. However, the number of drops of potato juice added should be doubled. So they're saying that we should leave the drops of phenolphthalein the same, but we should double the potato juice. And this might be interesting, because we might look at this and we go, oh, well, maybe the potato juice would compensate for it. But the problem is that we have no data to support how the doubled potato juice would compensate or not for the phenolphthalein. And so we cannot assume that. That's too much to assume for us. And so we're going to eliminate that. In general, if you don't have any kind of quantitative evidence to support an assumption like that, it's just wrong. So our answer choice is B, because that's all we're left with and makes the most sense.